Hello and welcome to the tutorial for the use of the CuticleTrace workflow. My name is Benjamin Lloyd, and I and my co-authors have developed a new analysis pipeline for capturing cell outlines of leaf cuticle using ImageJ and R. This is the tutorial associated with the manuscript here, CuticleTrace, a toolkit for capturing cell outlines of leaf cuticle with implications for paleoecology and paleoclimatology. This is currently posted on the bioRxiv, but by the time you see this video, this will probably be in Applications in Plant Science Open Access. Also linked below and linked in the paper is the CuticleTrace GitHub, which is where we'll find everything you need to actually install and begin working with CuticleTrace. I have it right here. It's github.com/benjloyd/cuticletrace. You can see the URL right here. This is everything that you need to get going with CuticleTrace. Once this video is published, a link to it will be here in the README. And the user manual is right here for a written repository of everything that we'll go over in this video. And all of the pieces of the workflow are all right here. So to get started, you can pull this repository if you are familiar with GitHub and use Git yourself, or you can just go to code and download the zip. Now, when we download the repository, we will see a folder or zip file pop up in your downloads or on your desktop or wherever your downloads go. This folder will include all of the folders that are in the GitHub at the time that you downloaded it. This includes the license and the README file, as well as the CuticleTrace user manual, which I would highly recommend having up while you watch this tutorial. This covers all the same material that we're going over today and in significantly more depth. The example dataset, which is right here, I've unzipped this already, and this has two subfolders, the example dataset and the example dataset complete for comparison. The example dataset is what we'll be using today. It includes 10 JPEG files, each of a piece of cuticle from the cuticle database, which is, all of these are publicly available images of leaf cuticle, as well as a CSV showing each of their scales in pixels per micron, which we will need to use to generate actual real measurements as opposed to just pixel measurements. The other folder, the one that is complete for comparison, includes that same information, the original data, as well as everything that we will be generating by using the CuticleTrace workflow. This includes all of our results, our measurements, as well as images with the results of the CuticleTrace workflow and the results of the subsequent filtering that we'll be using in R. Speaking of R, we have the CuticleTrace data filtration R markdown file. This is what we use once we have our cell outlines generated in ImageJ. We use the R markdown file to filter those based on statistical parameters. And finally, we have CuticleTrace allmacros.ijm, which is our set of all of the CuticleTrace ImageJ macros that we are now going to install into ImageJ to use to generate cell outlines from images of leaf cuticle. So now to get started in ImageJ, we're going to open ImageJ. In this case, we're using Fiji, actually, which is ImageJ with all the plugins. You should be using Fiji. It's the newest version. And we're going to click and drag CuticleTrace all macros into Fiji. There, you'll see a new ImageJ macro window open that includes all of the code in all of the macros in the CuticleTrace all macros file. All of this sets everything used for image analysis with CuticleTrace. The code is fairly well commented. But you do not need to be getting in here and changing the code itself to do what you need to do. It is all perfectly available for you to do so if you want to, but you shouldn't need to look at this really ever again once you install it. So to install it, we click back on the Fiji toolbar here, go to Plugins, and we go to Macros, Startup Macros. You may actually see that I've already installed these down here, so this is what we're looking for in the end. But to do this yourself for the first time, we go to Startup Macros. That will open a new tab in this code window with your startup macros here. These are all the macros that are automatically included in your toolbar when you open Fiji. So to get all of these into here, it's as simple as copy pasting them. So we'll just highlight the whole thing, Command or Control C, go down to the bottom of this, and just paste them in. Because I've already done it, I'm not going to do that. I have them all right here actually. But if you save Startup Macros, close Fiji, and reopen it, you will see all 4 CuticleTrace macros right here. Now that we have our macros installed, we can move on to image processing, as long as we have one more thing sorted. The batch generate ROIs and single image processor macros require the use of the shape smoothing plugin from the Biomed group. This can be installed as you would install any third-party Fiji plugin through the Fiji Updater. Once you have the shape smoothing plugin installed, then you can run any of the CuticleTrace macros. So now let's get started with some actual image processing with CuticleTrace. So the first part of batch processing images with CuticleTrace in Fiji is to determine your input parameters. This is actually the most time-consuming and difficult part of the process when working with new datasets, because you need to decide what inputs you're going to put into the CuticleTrace batch generate ROIs macro. We have tried to make this a slightly easier process, but it's still going to take some trial and error. To streamline that a little bit, we can use the CuticleTrace single image processor, which has all of these same input parameters that you would find in the batch generate ROIs macro. These, I won't go deep into every single one here, but these are essentially the same input parameters that you'll need to run a batch of images. We have in the single image processor, we have this desired outputs line where we can decide what we're actually looking for when we're processing a single image. So if we want, I don't know, just a thresholded image, if we're bringing in a unprocessed image and we just want to output a thresholded image, we can do that here. We can get a thresholded and skeletonized image, thresholded and skeletonized with the ROIs, and then we can input a scale and get the results out of it as well. Similarly, we can start with a thresholded image and get a skeletonized image with ROIs and results out of there, and we could also, start with a previously skeletonized image and get ROIs and or results. In this tutorial, I'm not going to go super in-depth on how to select input parameters for new datasets, but the basics of it is really just trying out new inputs for these input parameters, looking at the ROIs and the results that come out of it, and judging for yourself whether CuticleTrace is doing an adequate job of tracing cells. I'll give you a few examples to show what I mean here. So for this, let's just open up an image. So I'm going to close this so we can click and drag an image into here. Let's take this first one of a piece of honey locust cuticle. And let's go back to plugins, macros, single image processor. So in this case, we are using the default inputs because these default inputs are what we have used to process these images in the past. They're set to make this easy. But it doesn't have the scale inputted, so we can go back here to our example datasets scales, check this out, and it is 4.48 pixels per micron. So I'll put that in there, 4.48. And then we want thresholded and skeletonized image with ROIs and results, because we're starting from an unprocessed image and we want this to go all the way through the CuticleTrace pipeline. So let's hit OK. And it's iteratively thresholding the image here, smoothing it, then skeletonizing it, then generating ROIs, and creating an image with overlays showing each of the ROIs that it generated. We also now have a results file here showing the area, perimeter, coordinates, bounding boxes, foray, diameters, everything that we could possibly desire from these ROIs. And these, if this is not what you need, these can be set to be different things. And you can also take them and you can download this as a CSV, obviously, open it in R or in Excel or whatever you need, and do whatever math you need with these columns to get what you're after. So we can see with these input parameters, we did pretty well. We got accurate tracings of all the cells that we need. Obviously, we didn't get 100% of everything, but most of the ones that we're missing are ones that are cut off by the edge of the image, which we don't want anyway. And we have one kind of messed up double cell situation here and a little bit of issues here. These will come into play when we're statistically filtering with the R notebook that I'll talk about later. But overall, I would consider this to be a really great job. So now if we get rid of all these things and we try, don't save all that, we can try to do this again with a different set of input parameters. So if we go back to the single image processor, we still have the same original image open. Let's change this to NIBLAC, for example, and change the initial thresholding radius to, 10. Let's just give it a shot, see how it does. We can already see quite some differences in the thresholding and skeletonization. Things don't look quite as good. And as you can see here, things are not quite as good. We have some subdivisions of cells. We have some weird little ROIs. And some of the ROIs that do somewhat accurately trace a cell don't do it in a way that looks particularly cohesive and natural. Considering how these original thresholded images looked, it's not that bad. It does better than one might think. But again, the other thresholding algorithm and the different thresholding radius clearly did a better job here. So in this case, we would take the previous ones and move on to the batch processing. To batch process, we'll just get rid of all this. Don't save. Of course, if you're doing this to really decide your input parameters for a new data set, you'll need to write down or save your input parameters to these. In this case, the ideal input parameters for our example data set is actually the default ones that we put in there. So I don't have to worry about it. But now I've just opened up, let me cancel this so you can see, I've opened up the batch generate ROIs macro, which starts with a little notice that basically says the same things that are in the important notes of the single image processor. Again, reminding you that shape smoothing is necessary, and letting you know that all the input parameters that you put into here will be applied equally to all of the images that you're batch processing. This works because these input parameters often serve as a starting point. The thresholding radius, for example, gets iterated upon for each image. You can see more details in the paper and in the user manual. But things need to be in the same general ballpark for you to be able to batch process images together. So if you try to batch process and a small subset of your images are just not working, I would recommend just pulling those off to the side and doing those separately, because you might be able to get them to work in their own little batch as opposed to in your larger batch of your main images. The result should still be an accurate tracing of these images, so they should be cross-compatible. Like, you should be able to compare them to one another easily. Also, results files can only be generated if all images have the same scale. As you have noticed with our CSV, each of our images has a different scale. So with our batch generate ROIs macro here, we will not be able to actually get measurements of our ROIs of our cells with this macro, which is why we'll be able to use the batch measure different scales macro, one of the other CuticleTrace macros, to get our measurements after we do this. So to start, we are going to go to browse, and we have it set to images here. We have it in our example data set. That's perfect. So we're going to open that. Then we know that our cell walls and our background are dark on light. We're using all of the other default inputs for this, and we are not generating results files, so we're leaving that unchecked. So if we hit OK here, we're back to that exact same image as before. It's batch processing through that, and then we're moving on to new images here. So now I'll fast forward through this. All right, and now we have our list of images with the threshold radii and the interpolation intervals for all 10 images, and we should be able to see what they look like. All right, now we're back in the example dataset folder, which used to just have our folder of images and this CSV. But now we've got 3 new folders here. So we have our image metadata, which has the same CSV that just was left up on the screen in Fiji, with the thresholding radius and interpolation interval of each of the 10 images. And then little tiny CSVs for each image individually. This is an insurance policy in case the macro has hits an error and has to abort halfway through. We will still have the thresholding radius and interpolation interval of each image that does get processed. And then that gets compiled into one CSV at the very end, which will be generated if the macro works per the full batch. Then we have our skeletonized images, we have our ROI sets here. These are the ROI sets that can be overlaid in Fiji on each of the images, which we will be doing again to generate our overlay images and to get our measurements. We also have our skeletonized images that are generated in the process, as well as our thresholded images that are generated as the first step in the ROI generation. So our next step in the CuticleTrace image analysis pipeline is to generate our measurements of our ROIs that we have now generated. So at the moment we have our ROIs, but we haven't measured them. So to do that, we'll go back to Fiji and open up the batch measure different scales macro. Here we have to go back and select our CSV of image scales, and then we have to tell it what the names are of the two columns, the file names column and the scale column. These are already set to the example data set CSV, so we don't have to change these, but you might if you're doing this in the future. The image directory is the same as before. It's going to be images here. And the ROI set directory is the one that we just generated, and we have it there. So now let's hit OK. And we're going through and we're just measuring the ROIs that we've already generated for each of our 10 images. So that goes through, that's done that. And we should be able to go back over here, and we have a new folder that just showed up called results files. And here we have our area, perimeter, all of our things for all of the ROIs in each image. Okay. Now that we've generated our unfiltered results files for our 10 original images here, we might as well use our final Fiji macro to visualize the results of these original ROI generations. This macro is the batch overlay macro that allows us to overlay ROIs onto images, so we can easily visualize and qualitatively assess how CuticleTrace is performing. This macro has the requirement that each ROI set has the same name as the image that it corresponds to, except that where the image will just have its name and then .jpeg or .png or .tiff, the ROI set might have an additional string after the file name before the .zip extension. In our case, these unfiltered ROI sets, default naming convention is the image file name underscore ROI set.zip. So that's what ours are. To use this macro, we'll first select the path. In this case, we have the images here, and the ROI set directory is here. This is skipping ahead a little bit, but this is where they are. I've done a little work since I last filmed this section. So this is the zipped ones, the zipped unfiltered, and the example images. And we'll just call this folder images with overlays. And these input preferences allow you to decide what line width, line color, and shading you would like in your overlay. So if you're hoping to make figures, this can be helpful. These are hex codes of color. So this is bright yellow, and this is a transparent bright yellow. So we also want to label our ROIs so it's clear what is an ROI and what isn't. And here's a input for the font size. So let's run this and see what we get. All right, so that finished up just now, and here we have the images with overlays folder right here. We can see all of these images with the overlays overlaying on them, or with the ROI sets overlaying on them. We can qualitatively assess how CuticleTrace has done here, and we can see that in most cases it is selecting one single cell and outlining that cell accurately, but in an image like this, there are definite clusters of cells that get piled into one ROI, that would screw up our statistics and our morphological information if we didn't filter them out. So our next step is to use the CuticleTrace data filtering R notebook to statistically filter these out. So to do that, we move on out of Fiji and into RStudio. We will grab the CuticleTrace data filtration R notebook here and copy it into the example dataset directory. Our notebooks automatically set the working directory to the folder that they are in. So this makes it easy, keeps our file paths short, so that the working directory will always just be the example dataset folder. So now we'll open this in RStudio. We have it right here. And you can look through this on your own time. If we switch to visual, it's much easier to read. You can see all of the explanations of all the functions, well-commented code explaining everything that happens here. But overall, what this code does is it takes each results file, reformats it so that the file of each individual ROI is attached to the row that includes all the morphological measurements and information regarding that ROI, and then statistically trims those CSVs based on median statistics. So 1 or 2 median absolute deviations from the median, similar to 1 or 2 standard deviations from the mean. It does this by a variety of shape parameters, and with those measurements, we can generate new trimmed results files that only show the morphological data that we are after. With those, then we can trim our ROI sets based on those, so we can visualize which cells are being retained and which are being deleted. This works well as long as we set our file paths correctly. So the lines to do that are down here in the workflow section, lines 361 and 367. We want to make sure that these are the correct paths to get us where we want to be. So our results path, the directory path that contains our results files, is in fact, if this is our working directory, it's results_files, capital R, capital F. And our one for ROI sets is ROI, all capitals, _ sets, capital S. That is correct. So we can run this whole thing. The way that I like to do it is just hit knit. It will run the whole thing and output a nicely rendered HTML. So let's hit that, and we can see it's rendered it, which means that it all worked. And let's go back here and let's look at what we have. So on first glance, nothing looks different, but if we go to our results files, we'll see a new folder here, results reformatted. We have here reformatted CSVs that have the file names and paths associated with each ROI and the morphological data for each one. Then we have these 10 copied and trimmed to within 1 median absolute deviation of the median, or 2 median absolute deviations of the median. We then can go to our ROI sets folder here, and we'll see that we have unzipped versions of all of our ROI sets that include each individual ROI file, and zipped and unzipped versions of our 1MAD and 2MAD filtered ROI sets. If you're on a Windows machine, the code as it is currently written will not successfully re-zip these ROI sets, so you'll end up with just your unzipped ROI sets. Unfortunately, ImageJ and Fiji are not able to read unzipped ROI sets. You have to zip them for them to recognize what they are. So we suggest that you manually just highlight all these folders, zip them individually. Or you can go back to this part of the code here. It would be in this line here, and rewrite this to work on your machine. So now that we have these new ROI sets that are filtered, we can visualize how that filtering worked. We can go into our ROI sets folder, and we will just need to do a little bit of manual housekeeping here so that the batch overlay Fiji macro will work again on these new filtered ROI sets. So I'm going to sort these by kind, create a new folder, and I'll call that zipped. And another new folder that I'll call unzipped. I'll take these empty ones, copy them, put them in here, and I'll put them in here. So now we have an empty, zipped, and unzipped folder for the ROI sets folder and the 1MAD and 2MAD filtered ones. So we'll sort by kind. We'll take all the zipped ones, we'll put them in there. We'll take all the unzipped ones, we'll put them in here, and we'll do that for the 1MAD as well. All the zipped into the zipped folder, and all the unzipped into the unzipped folder. And finally, all the unzipped into the unzipped folder, and all the zipped into the zipped folder. Final housekeeping note, I like to put this in a ROI sets unfiltered folder, just for consistency. So now that we've done that, we should be able to open Fiji back up and overlay these ROI sets back over our original images here and see the effects of the filtering. So now let's give that a try. So let's go back over to Fiji and open up the batch overlay macro again. For this, we just want the same exact images as before. So we'll open those in the image directory. And for the ROI set directory, let's do the zipped, remember it has to be zipped, 2MAD filtered ROI sets. We'll rename this folder to be images with overlays 2MAD, so we don't overwrite anything and keep our folders straight, and we'll leave the image preferences the same. So let's hit OK, and you can see it goes through and overlays the 2MAD filtered ROI set on each image. We go back over here, we'll see that right here. We can open these up, use these for visualizations, for figures in a paper, for whatever you want. These then will also directly correspond with the results files, the 2MAD trimmed results. So you could use those overlaid images as visual aids while making graphs and doing analyses with these 2MAD CSVs. So that is it. Thank you for sticking with this tutorial on how to use the CuticleTrace image processing toolkit. As you saw in the video, we went over everything you need to know to process images with CuticleTrace, but we did not go in depth into how to select input parameters for ImageJ macros. To go deeper into that, go to section 4 of the CuticleTrace user manual. That should have in-depth information on everything you need to know for that. But basically, it is best to just try things and visualize them and work with it until you receive results that work for you. So thank you again for this, and good luck.